let's start looking at some types of addition reactions. So hydrogenation is a very specific type of addition reactions where we're adding hydrogen to alkenes or alkynes. So when you see that term hydrogenation, you will be expected to know that it is an addition process where we add hydrogen. So let's look at this graphic here where we see hydrogen being added to an alkene, and for every mole of double bond we will need a mole of hydrogen, and in the presence of a catalyst this addition process will happen and the product will be a saturated alkane. For an alkyne, we'll need 2 moles of hydrogen for each mole of triple bond, and in the presence of a catalyst will form the saturated alkane. So this is, I think, the easiest addition process that we're going to look at, because when we add hydrogen, we just add hydrogen to those carbon atoms that were previously in the double or triple bond to form the alkane. Now, hydrogenation as a process has come under scrutiny in recent years because it's used to convert unsaturated vegetable oils to saturated fatty acids. So the unsaturated vegetable oils always have cis bonds, and in the process of forming the saturated fatty acids from the plant oils, some of those cis bonds transform into trans bonds because the trans bond is actually energetically more stable. So the trans fatty acids have been linked to a lot of health issues. It appears that our bodies are not that good at digesting or clipping this trans bond, and we are well equipped to deal with the cis bonds that naturally occur in vegetable oils. So have you heard of trans fatty acid? As far as we know, it is not good for you, and now you know what it is, and it comes about through this process of hydrogenation. Alright, so let's put your knowledge to work. What I'd like you to do is pause this video, take a look at this alkene, and I want you to do a few things. 1, I want you to name this alkene. 2, I want you to draw out this reaction in line structure form and predict the product in line structure form, and then name the product as well. So pause this video and go ahead and do that. So let's look at naming this alkene. We see that there are 6 carbon atoms and no branches, and we want to give the double bond the smallest possible number. So this is going to be, this double bond starts on the 2 carbon. So this is 2-hexene. And before we look at the line structure, I just want to point out that this alkene can exist in the trans or cis formation because each carbon in this double bond has a hydrogen. So we're not told whether this is, and not only hydrogen, but it's also bonded to some carbon containing things. So this could be cis or trans, and we're not told which it is, and we're not told to identify that. So we'll just assume it's trans because it's just easier to write the line structure that way. So here's the line structure of 2-hexene, and when we add hydrogen across that double bond, we get the saturated alkane, and the name of the alkane would be hexane. So if you got that right, give yourself a pat on the back.